So my first thought in this question was that if minus 2 is one of the roots, then it has to satisfy that equation. And that means, doesn't that give me the value of r? And I'm sure others will have this thought as well. But if you do this, you'll see you'll get 4 here, and then that would be 8r plus 4. And then this is a minus 2 here, so we'll get minus 8r plus 2 equal to 0. You'll note the r term drops out, and then this 4, 6, 8, so it does satisfy. That means that no matter what you choose for r, this will always have minus 2 as one of the roots. So that wasn't something I was expecting, and this is going to happen in the exam. Generally, you know the established methods of approaching, but sometimes this is what will happen. So then the next thought was, if I know minus 2 is a root, that means x plus 2 is a factor. That means I can divide this cubic equation. It has to be divisible, and I will get the quadratic factor after I factor it, x plus 2 out of this. And so I'll do the long division here, x cubed plus 2x squared. And then you have to, of course, be careful with the r here. So this will become 2rx squared plus x squared, and then minus 2x squared. So that would be minus x squared. And then I move this term down here. And if you factor out the x squared, you get 2r minus 1. So next I'm going to multiply it by x times 2r minus 1, because then this will be the product when I multiply by the x term. And then I'll get plus 2 times that term, which would be 2x 2r minus 1. So these two would drop out, and I will actually do it by expanding it, just so I make sure I don't make a mistake. Minus 4rx, and then because it's a minus 2x will become plus 2x. So you do want to be careful with these computations. And then I move this 2 here, and then you'll note if I put a 1 here, you get exactly x plus 2, and the remainder should be 0. And it's independent of the value of r, as we saw here. So this is the factored form, and we can equate this to 0 to find the other two roots. Now the condition is that they need to be real. And so if I know my general quadratic, the condition is that the discriminant b squared minus 4ac has to be greater than or equal to 0. Equal would be when the two roots are identical. So we apply that here. B is 2r minus 1. And then a is 1, c is 1. That's the condition. So I'm actually not going to expand this, as you will see, because 4 is a perfect square. And you can think of this, if you ever see this kind of inequality, think of it on the number line. So if this 2r minus 1 has to be greater than or equal to 4, so that's one condition. Sorry, 2, the square root of 4. Or on the other side, has to be less than minus 2. So those are my two conditions. And if you look at this one, that's going to give me r is greater than or equal to 3 over 2. This will give me 2r is minus 1, r is less than minus half. We're looking for the minimum possible non-negative integer. So I have to look at this case. And we're looking at integer values. The least would be 2. So past 3 over 2 of 1.5. So the answer is 2. And if you're interested, you can find those two roots, or just maybe for your own interest, and graph it in a graphing calculator. You'll see the two roots are real. So answer is 2.